who I know here, some friends, people I don't know. Um, a little bit about Five9. Five9 is a contact center in the cloud. I'm working in outbound campaigns. So when you get a call from, I don't know, your last store, and they want to know if you enjoy your previous experience. This is what I'm doing here. We are hiring, and the benefits are very good. And if anyone want to join Five9, we can talk later. Uh, so I'm gonna talk about ChatGPT, and we're gonna dive a little bit into what is backing up ChatGPT. Uh, that is artificial neural networks. It's something. Oh shit. Uh, it's something. It's something important to talk about, mainly with the recent news. In I think was Monday, they announced the Nobel Prize winning, and uh, there was two guys that invented neural networks. So, and I was reading about the biography of the guy. One of those guys were working in Google in the early 2000s, and the guy left Google because he wanted to speak more freely about AI. So it's very important so that we understand a little bit what this kind of tool is doing, and how dangerous it is, and how useful it is, because everything has two sides. So we're gonna dive. It's avoidable. It's not. We can avoid to dive into the math of the thing. I'll try to simplify it a lot, but we're gonna talk a little bit about the how this math and computer scale allowed neural networks to power such big applications in complex real life problems. And we're gonna see that neural network just understand vectors, and how we can transform everything in vectors, like words in vectors and then texts in vectors, and how this enabled ChatGPT to came alive. So a little bit about me. I'm a Brazilian software engineer. I was born in Belo Horizonte, Minas Gerais. Not a lot of people know the city. It's the city where we lost the 2014 World Cup to Germany for 7-1. That was the city. I already said that I'm working out in outbound campaigns. I've been working with Java stuff, backend stuff for the last 10 years. So kind of strange that I'm in a front-end tech talk. This is because we are speaking about AI and not Node and not React or Angular or anything like that. Just because I have no experience with front-end. And I started working in 2009 in intelligent system lab in this institution in Brazil, the institution that I graduated, and I took my master's. I didn't start undergrad at 2009. I was very young. I was in a technical high school, and I was working in a project that was very different from current AI paradigm. It was kind of bio-inspired artificial life simulator. It was kind of a mini game, something like that. But something very interesting happened in 2009, that Sony released the brand new camera called Cybershot. And that camera had a very cool functionality, because it was called Smile Shutter. So the camera was able to identify if people in the photo was smiling, and if everybody was smiling, it shoot the photo automatically. No time is involved, no clicks. And you imagine that I was in high school. I was just starting with basic algebra, and my colleagues, everybody was, oh, that's so cool. That's very innovative and disruptive. And one of my friends, his old brother, was already doing graduation in computer science, and the guy said, oh, my brother said to me, this is just matrix multiplication. And I kind of felt like that. Uh, we kind of knew nothing about algebra, and we are simplifying this stuff a lot. And when you start getting learning, you're gonna struggle a little bit with how this matrix multiplication works and how all these linear equations work. And at some point, you gain some confidence. You start undergrad and you start seeing that a lot and seeing the applications, and you realize at the end that, yeah, this is just matrix multiplication. With ChatGPT today, is kind of the same thing. There's a lot of people that don't know exactly how this thing works and say, oh, this is just predicting the next word. I read that in a blog. There's a lot of people as well that is actually doing the thing and studying the thing, and they actually know that is just predicting the next word. And there's some people in the middle that, oh, this is the AI and gonna take over of all of our jobs. Question? No? Okay. So, and how this thing starts, uh, actually it is a lot of matrix multiplication, and all these matrix multiplications behind the artificial neural network. This thing exists since the 60s, and it's been used in science and computer science since it was proposed. But at that time, we didn't have enough computer power, so we could do very simple stuff. And just recently, with Moore laws, that computers just get more powerful every 18 months. In 2013, was the first paper that broke the state of art. It was AlexNet used to image recognition. And since then, that thing blown everything. So nobody today do research in AI and don't use neural networks. But actually, what is an artificial neuron? You see that depicted in blogs and books like that. There's a set of inputs, a set of weights. You join everything up in a function. They call it activation function. It's a very fancy name, and you have the output. But there's a very simple and compact way to represent that mathematically. It's just a function, mathematical function that gets two inputs vector, multiply them. If you don't know how to multiply two vectors, it's pretty simple. You multiply the first number with the first number of the second vector, each one pairwise, and then you sum everything up. This produces a number, and you input that to that sigmoid function. Could be any other function. The sigmoid function is just very special. It has a special property that turns any real number in something that is a probability-like number. And we're gonna see that in neural networks, probabilities are very important. So this is kind of a lot of math, I know. I promise that's gonna be simpler and gonna be clear, a little bit clear. How do I code a neural network? That's simple. It's a very small code. This is the code for the neuron that I represented before. You can, it's just three functions. You can stack them as you want and make as many layers, as many inputs, as many outputs you want. You can combine them in very different way, and this is uh, the one of the most powerful things of this this tool, that you can barely model anything with a neural network. What about training? Uh, when you see it, when you see in papers and you see that, oh, we trained a model, that's another math class. It's not gonna be for today, but I can try to explain that simple. For train a neural network, you need a lot of data, uh, and you have a, for example, we can train a neural network to predict the prices of houses in Porto. That would be very interesting. Uh, so I can go to Idealist and get all the house sizes and house prices and train a model. So I'll input the house sizes and all the parameters that I want in the X, and I will initialize W with random values, and I'll have predictions. These predictions will be completely wrong because the parameters of the network, they are random. But I know the real value, so I calculate the error. That's what I predict minus the actual value, and I'll propagate that to the weights, and we do that over and over and over and over again until we get a very small text of error. This algorithm is the back propagation, uh, kind of, but that's the name, and that's how it works in a simple way. But okay, we know that neural networks just receive vectors, but we talk words and ChatGPT produce words. How do we get words into that thing? We can transform that in vectors. And how we do that? We can use a neural network to produce those vectors for us. And I think this is one of the coolest part of, of these large language models. And as we have a lot of computer power, we have very powerful computers today, we can do that in a very big vectors, in a very high dimension, if I would say mathematically correct. So suppose that I have this data set, is a very small data set, it's just 5 words. I want to predict this word. How do I transform that in vectors? So first of all, I'll transform my vectors, my words in a dictionary, in a binary dictionary. So I have a binary representation for each word. And I'm gonna input these words into the network in a very clever way, because I'll try to I wanna the output to be the word in the middle. So you're gonna understand with the animation. Uh, so I'll pick the words that are in the outside window, and I wanna the network to predict the word predict. Uh, so it's gonna output the value of in the binary dictionary. I love this animation. And the clever thing is that the vector is the output of the inner layer of the network. This is called WordVec. It's a paper published by a guy in Google in 2013. And these vectors have a very special property, because we can sum them and subtract them, and we're gonna get some meaning of those operations. Let's try a little test here. I have the vector that represents Lisbon, and I subtract from that vector the word Portugal and add France. What is the expected output? No. Anyone else? Think about the meaning of the words. Like, Lisbon is the capital of Portugal. if I subtract Portugal from, sorry? Paris, yes. Okay. And the same thing for example, for brother minus man plus woman, it's sister. Yeah, that's easy. Yeah, I should put that for in the first place. So there's meaning in the vectors that we can like join vectors, subtract vectors, and that's very cool. But we are still talking about just words, and text is just a sequence of words. So we have to input that to a network. How can we do that? One of the first problems that this kind of network was used is for translation. So we're gonna try to translate a phrase that I love you from English to Portuguese. And we're gonna see one of the techniques that is called recurrent neural networks. So one thing that I can do is input word by word to the network. But the network from the simple setup don't have a way to remember the last word that I input. So how can I do that? I just connect the output back into the input. This is uh, this is from the recurrent in the name comes from. So I'm gonna input I, and the network has to predict eu. I'm gonna input love, and things start getting strange because love and chi don't translate actually, but you wanna train the network to give a good translation. So sometimes it gets wrong in the middle all the way, and to get right at the end, because the network has to look into the context of the whole phrase. This is one way of doing this, but it's not very performant. If you remember using Google Translate before the 2013, I don't even remember if it was Google Translate back then, but if you remember using it in the first versions, it was very bad translating big text, because this technique has a problem of I have to accumulate a lot of context in a very small uh, setup, in a very small memory, and sometimes I lose track of the context. So for keeping the context in the whole text, I can try to correlate the text with itself. We're gonna see a little bit of that. It's kind of a big simplification again, but for example, if I want to correlate the phrase I love you with I love you again, so see how which word interact with each other. Yeah, something that I missed here. Uh, that was a problem because long texts have different grammatical structures, and something that I want to differentiate as well is that words in different parts of the text have different meanings. So I want to see how these words interact with each other and how those meanings interact with each other. This is the thing. So for example, in the phrase I love you, I and love relate a lot to each other because I is the subject of the phrase and love is the verb. And love and you also relate a lot with each other, so they have a high number. It's closer to one because you is the predicate of the phrase. A little bit of Portuguese as well, or grammar actually. Uh, and but I and you don't correlate a lot because they don't have a direct relationship inside the phrase. That's confusing. Yeah. But that's called what Google called the transformer architecture. It's how I understand grammatically structures in the text. It's just like a big matrix of the whole text and how this text correlate inside, like how I understand the context. So instead of understand the context in a very small vector or in a very small input to the network, I have a whole matrix, a big, very big matrix that that contains these context. And yeah, if you see the very small box there, this is what is called the attention mechanism, or the uh, transformer architecture, and not those transformers there. So about the G and the P in the chat GPT, we saw that the training process, the T is for the transformer that we just saw, this big matrix. And the P is for the training process. So usually you have just one step of training in a network, and then you have the inference phase that you're gonna like actually use it to make a product. ChatGPT has two training phases. First of all, it's gonna train in a large data set in a unsupervised fashion. That is, and unsupervised means that I'm gonna train a data set that I don't know the answers. I'll just go through the data and try to abstract from that data. And after that, I'll train my network in a very curated data set, a very it's a prepared data set that I know the answers. And the G in ChatGPT stands for generative, because at the end it's trying to predict text and generate at the same time. So this is one picture of the paper. The paper is not very long and not very clarifying. And if you read that without reading the previous ones, it's even worse. So this here, this small box inside this blue box is the attention mechanism, and what we saw in the previous that big matrix I spoke about. This feed forward net is just a regular neural network. It's very big. The 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 previous box, the attention mechanism, is where the ChatGPT is learning the structure and the context of the text, and the feed forward is where ChatGPT store facts and store knowledge about the the data set that it the data that the model have seen. This block is repeated 12 times, so this is why this is very big. And why magic? They don't tell why they. It's just that probably they trained it with 1, 2, 3, 4, and they saw the performance increasing, and at some point the performance wasn't increasing anymore. And this is the model that is trained in a general way, in the pre-training phase, and the post-training phase is they combine the input in a very clever way, very curated for each task. For example, for text classification, they train in in a in the first architecture. For entitlement, they train the second architecture. For similarity, they train the third architecture. So they prepare the model, and it's very specific model for every task. So what about AGI? That the, like, when we talk about general artificial intelligence, that depends of what we consider general for intelligence. And when you see these kind of models uh, interacting with us, it looks like human interaction, but human intelligence is the most general that we know, and language is just an aspect of it. So we can do a lot of things that don't relate to language, and we still call us intelligent. Uh, and intelligence is the behavior of creatures that have nervous systems. So fishes are intelligent, dogs are intelligent. We call all those things intelligence. And this nervous system controls a lot of vital activity. And for as far as we know, the human brain is the most general one. It's very complex, and we call it a complex adaptive system. And this neural nervous system was tailored through evolution for 500, 540 million years from the first vertebrates to us. And when you compare the human brain with GPT, the human brain has 86 billion neurons with 100 trillion connections, while GPT has like, and all those connections are flexible. And GPT has 1.76, it's missing a billion there, but it's a billion fixed around per meter. So GPT cannot adapt, and any neural network, artificial neural network, cannot adapt to new data automatically. You train it and you deliver to production. So that said, we can argument against the artificial general intelligence that GPT only deals with written human language, and there's a lot of different human languages. For example, sign language, and it's very hard to train a network on that. It has a phase of learning and a phase of inference, so it doesn't learn continuously as we humans do, and not every living creature does. Uh, and it learns over a very well curated data set. And in 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 this kind of stuff, like in this kind of problem, you have to train it in a very specific way. It's very hard to generalize a model. Like if I'm training that for pure text, to generalize to math or for code, for example. And it's very power consuming. Like our brain takes like 20 watts of energy. This is kind of 20% of our body resources. And GPT-3, just for training, it took 100 megawatt. This is a small city in the US. This is the consumption of a small city in the US in a month. And I think it was trained for like 3 months and something. So that's very power consuming. Just for training, the inference phase is also very power consuming. And there's just two ways of scaling it: or I add more computer power, or I add more data. And we know how to do the first one. And you see people like Mark Zuckerberg saying that they're gonna build a nuclear power using to power these models. It's just because we need more computer, you need more power. There's no free lunch, and you add more data, and we cannot scale data anymore. Like we already trained the model in everything that we know, and the only way to scale it is sit and wait for the humanity to produce more data for us. And there's arguments in favor of like GPT is already general enough. If you interact that with text, it can translate between different languages seamlessly. It don't commit mistakes like grammar mistakes and stuff. It can store huge amount of information in a very compact way. Like GPT-4 is just 7.2 terabytes if you do like a really simple math that you take the number of parameters and multiply that for a floating point size that is 4 bytes, I think. And it can do math, and there's a lot of research in applying these large language models in different problems. For example, math is one that is very hard uh, to to abstract because you don't have enough data. So you have to be more clever, but you can. And like you can put these things to prove theorems and prove stuff that's not proven yet. And might be just a bunch of matrix multiplications, but still a good. It's still good in making products. And so final remarks on that. What I believe and I think these large language models they're gonna blend in our life and become something of ubiquitous in our productive tools. I don't remember the last time I didn't use Translate to do something, Google Translate, and this is a large language model that we've been using for like years now. And AI is based on neural networks. They just produce stuff that they seen in training, and that's very important. It cannot invent. It has no creativity. If you ask ChatGPT to invent a new word, it cannot, because it's trained in a limited amount of tokens. And this also doesn't mean that it's not dangerous. I think the most dangerous stuff is the power consumption. Uh, in the moment that we need to transition um, for greener power sources, it's very dangerous, and they are trained in every piece of data, and that's very dangerous for intellectual property, for example, serious journalism, and also we've seen in democracy and elections. So that was my final slide. If you have any questions, I think yeah. Okay. Questions. Okay.
So thank you, Felipe. Thank you for having this awesome talk. And I would say like suck it, ChatGPT. So guys, I would do like 5 minutes. If you guys want to go to the bathroom or something, drink some water, and start with Yori. So for setting up, so feel free to go to the bathroom or just stay looking up. Yeah. Da hora. There's no problem, Jordy. Uh, so yeah, guys, let's start again. Yes, fine.
We have a pet now.
What's the name?
I don't remember its French. I know the Brazilian one.
Fule.
No, no, that's from the word cat.
Yeah.
What's there? Is her? I don't know. Name? It's a French cat.
Yeah. So guys, let's start again. So thank you again for drinking water. So Hordi, we met like in the last meetup, and after we drink like some beers, he had like such a great topic for presenting. You guys going to see. I'm not going to spoil something. You guys can like discuss with him democracy later. It's always awesome. So thank you, Jordi, and it's great. Like we say, like that you guys should talk with us. So Hordi is like being. I think it's the first one that no, it's the second one.
No,
The first international, yes.
first international speaker.
Yeah. So we're pretty proud. So thank you, Jordi. And I know that you're going to rock. So I guess let's. It's fine like this. It's fine like this.
Perfect.
Yeah, cool. Super. So yeah, hi everyone. I'm Jordi. I'm coming from Barcelona, Catalonia, and now I'm living in Porto. Uh, I wanted to give this talk because since I'm like 7 years ago, I'm very into the topic of governance, digital democracy, and all this cool stuff. And yeah, I think we nowadays we have a problem with democracy, and I think that technology can help a lot. So I'm not going to solve democracy here and now, but I think we can reimagine the way that we interact with democracy, and I think technology has a lot to do with it. So that's why I chose this title for the presentation. So it's reimagining democracy, and yeah, when I started all this thing about governance, digital governance, I was that was back in 2015. I was uh, learning and interacting with blockchain. I mean, this cool technology that appeared in 2009. It started with Bitcoin. But yeah, I saw something that it was like more ahead that just cryptocurrencies. So the base layer, the blockchain technology. And I think democracy and blockchain technology are good allies, and we can solve one of the biggest problems of digital democracy, which is voting. And yeah, I think blockchain technology will not transform, is already transforming decision making. So yeah, this will be the topic. I created an index or guide you through a talk. First, I will give a bit of background. I will do an introduction and why I think democracy is at crossroads. And I will introduce you to the blockchain, a potential game changer for democracy, from my point of view. How many of you know about blockchain or Bitcoin or cryptocurrency in general, have slightly idea? Cool. Perfect. So we will transition from blockchain to digital voting using blockchain technology. And I will explain later the case of the DAOs, which are the decentralized autonomous organizations, organizations that are internet native. And I think they're something that work out. And for me, I try to understand it as the first sandbox for a new way of decision making and for interacting between all of us. I will explain a real world use cases. I'm contributing in a project which is called Voice Donny. It's written in Esperanto and means to give voice. And it uses blockchain technology for giving people an easy to use protocol and UI for voting. And then I would like to ask you what's next.
what's next in this field. And I know that this thing about digital voting is a very controversial topic. It's been around since, I don't know, 25 years ago. There has been a lot of fails, uh, lots of hacks, and people are afraid to vote digitally because either they think that their identity will be revealed, their vote will be tampered, or people will cheat on the elections, basically. Uh, I think this was true until blockchain technology appeared. So I think right now we're in the proper moment to start like going hard into this thing. So yeah, that is expected to be a technology talk, but um, pardon me, I need to introduce some kind of politics, governance, and mix everything with technology, which is like the cool thing, I think. Cool. So first of all, democracy. It's maybe one of the coolest forms of governing that we have. Otherwise, we end up in dictatorships, for example. So I think democracy is a good trade-off for managing the society, and I think it's important to start with some principles. So, what's democracy about? Democracy is about participation of citizens. So everyone has the right to participate in the decision making. It's about equality. So everyone is the same. We are all citizens, we're all people, and we are not uh, more than anyone else. It's about accountability. So when we decide on something, we expect this something that should be implemented. And if not, someone should be held accountable for not doing so. Then it's about transparency. So if we decide on something, and for example, in representative democracy, we delegate to our representative the decisions that we want they to make, they should be transparent with us, with the decision that they made, and with the steps that they took for reaching our end goal. It's about tolerance. Everyone has an opinion. Everyone thinks different. We have groups, tribes with different, let's say, objectives, different thinkings, but everything is fine as long as we understand each other in some way and we respect each other and we tolerate each other. Also, it's important in democracy to have more than one choice. Otherwise, if you can only vote to one person, that's not democracy at all. Maybe it's kind of a dictatorship. Democracy is also about the control, the abuse of power. So that's why accountability it's mentioned above. Also, there's something really important in democracy, which is like the freedom of economy. And more important than that for me is like the freedom to transact. We need to be free to do whatever we want with the resources that we have, as long as we don't damage anyone else or we don't do anything bad to the society. It's about a bill of rights. So we have like a set of rules written that everyone should respect, and if not, they should be accountable for that. It's about human rights. They're like we have like this super cool letter from the United Nations where we have like the minimum stuff that we need to comply with to be considered like humans and to respect the human being. It's about free and fair elections. Free is very important because as citizens, we should have the right to vote and to decide for free. So there's nothing in exchange. Also, free courts. If someone acts badly or we want some clarification, we should be able to go to a court without any cost, because this is implied in most of the principles that I've been talking about. And also, rules acceptance. This is a hot topic lately. Maybe you have a different opinion, but if the majority thinks that your opinion is not really good and they agree um, to decide something else, I mean, you should accept the results next time. It will be your proper time. And the other one, I mean, and the last one is the rule of law. So we have some laws that we should comply about. I mean, we should comply. Sorry, not complain. maybe we can complain sometimes. So we have rights and we have to comply with the law. So I think this is really important to think about it, and this is what will set the basis for the rest of the talk. And yeah, I just wanted to make few questions that you don't need to speak out loud for answering them, but just to think about it. So how do you feel about democracy nowadays? So do you trust the people you vote? Do you think you have a voice on decisions that truly matter? How often you decide? How often you choose a representative? How often can you speak up your voice when something is not good for you or you want to change something to improve it? And which are the mechanisms that you have for sharing what you think and to take action, which is like the important part here, because we have social networks. We can, I mean, in the web 2.0, you can write a post on Facebook and everyone will read it, but actually, okay, cool. But then what else you can do? And what can you do if you are not being heard? What can you do if you have a problem and your problem stays with you and you don't have any way to communicate or to solve this problem? Where is accountability? Where I think everyone is kind of I don't know how to say this in English. I mean, we are tired of seeing politics promising something and then they basically do nothing about the things that they asked, or making some bad decisions or some bad decisions with bad intentions and nothing happens. Of course, if you kill someone, you go to jail, but there are things that kill indirectly. So yeah, I think we should enforce more accountability on our representatives. And the last question, and especially during the past, I don't know, 100 to 100 years, we are, I think, do you think we are polarized as a society? Because as I see it, you are from the left side or you are from the right side, and if you are in the center, it's like, oh, you're in the center. You are in the other part. So it's very difficult to reach agreements because our positions are so contraposed that, I mean, there's no middle path. There's no politics here. So yeah, this conducts me to expressing some facts. So we can say that there's an erosion of trust in politics and in governance. The power is centralized. There's unaccountability. There's polarization, and polarization leads to gridlocks. So these 4 years, I will, for example, I will make left-wing politics to try to help the people that needs uh, more help from the government, for example, because they don't have good healthcare, they don't have good wages, whatever. But then 4 years pass and the other political party wins, and then we erase everything and we start again. So we are not really advancing. Also, exclusion. There's a lot of people in this world that cannot participate in politics and are excluded. Decision making is really slow and it's inefficient in a world that it changes every time faster and faster and faster. We're still using analogic systems for a digital world in terms of decision making. And the last one that for me is very important, voting is exclusive and expensive. You as a citizen cannot organize a voting process. Maybe you can go to the government, try to recollect some signatures, create a popular legislative initiative, and bring it to the government, and let's see what happens. And this is expensive in terms of infrastructure, and if you want to do something that complies with the law, it's really, really expensive. And I would like to make a point here. The census is private. So how can you organize a decision-making process if you don't know who is allowed to vote? And I mean, there are good reasons for doing so, because there's private data of the people, there's stuff that should be hidden from the public, but well, we have, thankfully, we have math, we have cryptography, and this can be solved. But census, the census of the citizens, for me, should be public, because you should be able to organize an election and know who has the right or not to vote. So yeah, after this introduction that is not like very positive, I think we as a society we can say that democracy is at crossroads. Or we reinvent it in some way, or we are fucked up, basically, because people doesn't trust institutions, we don't trust each other, we don't have mechanisms for reaching agreements, and this is a bad thing. And well, I think it's not a good thing to end like in a third world war. So yeah, setting governance and politics apart, I would like to explain like basics of the blockchain and why this is useful for decision making. So let's enter the blockchain. What's a blockchain? Really easy. A blockchain is an immutable distributed registry. So it's a list or a ledger that keeps a permanent and organized record of entries with two key properties. First one, immutability. So once the data is stored into the registry, it cannot be changed, it cannot be altered, and it cannot be deleted. And the second one, distribution. The storage of this data is distributed across multiple computers or nodes. So each server, each node, each computer maintains a copy of the same data in consensus, which is a really important part. So everyone has the same data. So there's a good analogy that can explain like blockchain better. That's with the appreciation of blockchain technology, we are changing how internet works. So we are transitioning from the read-write internet to the read-write own internet. Web 2.0 is about data transfer, and Web 3.0, which is like the normal way to call all this blockchain craziness, is that right now, apart from data, we can transfer value. And if you think about a vote is a very valuable asset, as well as it is cryptocurrencies or some digital art or different ways of value representation. And the other thing is that we are pushing the change from a centralized internet to a decentralized internet. Your information, your personal information, is valuable. That's why all this big tech, Facebook, Google, made tons of billions of dollars using our information. So this is something about take what belongs to us back. And how does blockchain relate to governance? Think that with blockchain technology, we can provide a decentralized, distributed, a transparent, and a secure framework that can reshape governance, democracy, and decision making. Why? Because we have immutable records. So if we cast a vote, it cannot be changed. And everyone knows that this vote was casted. We can enforce rules. So apart from these cryptocurrencies, in the blockchain, we have virtual machines. Ethereum, for example, is a project that it codifies a virtual machine. So the blockchain, the nodes are running a distributed immutable virtual machine. So maybe we can transfer the voting process to this virtual machine. And this can be written in software in a thing that is called smart contracts. So this is like a program that runs in a distributed way in every machine that participates in the network. So for each machine should be able to run a voting process. It's about auditability. Everything is based on cryptography, on math. 1 plus 1 is 2. The same for a vote. If your vote is represented by 1, on the tally will appear a 1. And this cannot be changed, and you can audit all the phases of the voting. So there's no way anyone can tamper your vote. It's about transparency. All the technology is written in a free and open source mindset. All the code is publicly available. Everything can be checked, double checked. You can experiment, you can find bugs, you can find everything. It's about security. These networks are, for example, the Bitcoin network are secured by electricity usage. Ethereum network is secured by stake. So people are putting money to receive an incentive if they act well. And if they act bad, well, they got sliced. Sorry that I forgot to mention, I got a cold yesterday and I need to take care of my nose sometimes. So sorry that if this interrupts you or shifts your attention. It's also about global accessibility. So Bitcoin and well, starting from the internet allowed us to globally access a set of data. So the world is really better thanks to the internet. So now we can transfer value. So we can transfer value anywhere in the world. And it's unstoppable. No one can stop it. So with all these things, I think it's a good moment to take the governance ownership back. So, okay, digital voting. Voting is a key element in democracy and in decision making. And the world is digital and is moving fast. But as I said, decision making is slow and analogic. And what happened, for example, if we make these questions? What if we can decide and participate more and more often? What if we can have a say that is enforced by law? And the law is the code that we have written. Why not experiment with the new forms of voting? So normally we vote for a political party or for a representative, but what if we can express our desires, what we think, and this can be translated to a vote without electing anything directly? Or what if we, instead of choosing just one option, we can balance, we can have a weight, for example, 100 points, and we can distribute this weight. So these different ways that we can vote. But what's the problem with the digital voting until now? There is fear and a long track of failures. We have seen polling stations in the United States, electronic polling stations in the United States. We have seen in Switzerland almost invalidate 5 years of election because there was a company that were using like a centralized voting system, and a guy found the bug, and that basically allowed you to change the votes. And why this happened? Because it was not open, it was centralized, it was a private system. They enforce like security by obfuscation, which is like the worst thing you can do. And they use trusted systems. So this using blockchain technology for me is just a paradigm shift. So what's missing for having like a proper digital voting system? We need an immutable distributed registry. We need a blockchain. We need digital identity. For example, if you don't know, your passport is electronic. So in your passport, you have cryptographic proof that a centralized authority, that your government, for example, that are signing that you are who you are, where you live, what is your nationality. We also have like the European Union digital identity that will come in the following years. So it's expected that in 2028, every European citizen have a digital wallet in their electronic device that has, for example, the driving license, your studies titles, and whatever is required for interacting with, let's say, the public administration. We also have national IDs. For example, in Estonia, they have like a really long track record of voting digitally. In India, most of the people have a digital identity. And then we have some, this, if you think about it, at the end are centralized ways of identifying a citizen, because you depend on the government. So the government can just delete your passport. They can invalidate it, and then, yeah, so you don't have nationality, you don't have identity, you don't have anything. But well, maybe we can use decentralized identities, where, for example, I'm Jordi, and why people know that I'm Jordi? Because Fabio say it, because Luis say it, because my family can say this is Jordi, was born in this year, and so on. So we can make attestations in an identity that we can create by ourselves. So we can have like cryptographic proof that we are what we say that we are. And then the last part, which I already mentioned, is openness. So we need a free and open source mindset. Digital voting will never work with centralized and trusted systems. We need to have every piece of the system public. We should be able to audit it. We should be able to run elections in our home computer. We should be able to verify the tally of an election in our mobile phone. That's the only way. And in 2022, one of my colleagues wrote a response to the MIT. The MIT released like a paper that was called something like blockchain voting from the bad to the worse. Like, we thought, for me, even understanding what are the cool properties about the system. So my colleague wrote like a replica, let's say, that it was, if you go to the MIT law webpage, you can see like all the document. I can share you the link later. And this is well explained. But the cool thing that I wanted to mention, and for me is the important part, is that in a digital voting system, there are properties that cannot be negotiated, because this is how analogical voting works. So you need to have ballot privacy. Anyone, any observer can determine the contents of your specific vote, because that's a privacy problem. We need receipt freeness. This is really, really important on digital voting. This is about vote buying. So vote buying in an analogical world is not scalable. So maybe you can buy 3, 4, 10, 100 votes, but this is not representative in a big election. But with software, you can do it, because if you can present a proof to someone that you voted something, you can just create a program that automatically distributes funds to anyone that voted what you are demanding. So we need receipt freeness on digital voting, and it's really important here. And we need coercion resistance. So during an election, a voter cannot prove their vote to a coercer. If someone comes to my home and say, with a gun, say, vote this, I'm fucked up. So the idea here is that even if someone does this, I should be able to change my vote later. And I should not have any way to prove to the coercer that I voted something. Then, censorship resistant. No party, even the administration of the election, can censor a valid vote, because voting is a human right. Non-repudiation. Any party can modify or erase a vote that has been cast. So all the votes, if they are valid in the terms that the software says, should be valid and accountable, and no one can modify or change the vote. Also, correct execution. No party can forge a false tally of the voting. So you should be able to mathematically prove that the tally is correctly computed, and no one can add or subtract votes. And then, individual verifiability. A voter can verify that their ballot was correctly contained in a set of published results. So when you vote digitally, normally you get an identification that at the end of the vote, you can verify that everything was fine, and their ballot was correctly contained on the tally. Then, universal verifiability. Anyone should be able to verify the results. Anyone should be able to take all the data of the voting and in their home machine verify that everything was counted correctly. And it's very easy, because it's a software that is codifies a mathematical function, and the output is deterministic. So it's really easy to do so. Also, eligibility verifiability. Sorry, anyone can verify that each vote that was included in the results was cast by an eligible voter, and no one casted more than one vote if the system doesn't allow to do so. So we cannot double the vote. We cannot vote 2, 3, 4 times. And with those three properties, we can say that we need for digital voting end-to-end verifiability. So it's like the end-to-end testing. So you, from the point that you are executing the program that runs through n processes, you should be able to verify that everything works correct and perfectly. Okay, so this is a super simple schema of how the system can work or works. So technical approach. We have an ID issuer. It can be a government, it can be yourself with attestation from other people that says that you're a citizen. So as a citizen, you can have like two roles. You can create a process or you can vote. So what does the process creator do? So we have a blockchain. Remember, this immutable distributed registry. So you're sending the voting information to this blockchain. And then the voter, one of the things that can do is to, when the voting starts, they cast their vote, and their vote is registered into the blockchain. And that's fine. The vote at the end will be counted, the tally will be done, and everything is fine. But well, blockchain is a kind of a new technology, and we have like what we say scalability problems. So it's very resource consuming, and then we need to find out some other solutions. And also, it's too transparent. So what happens if you send your vote unencrypted? And if you encrypt your vote with your key, everyone should need the keys of everyone for later decrypting the vote. And then if they decrypt the vote, they will know who voted and the inclination of their vote. So here we are using something that is called zero knowledge. It is like a magical stuff that I'm not a cryptographer, so I don't know how to explain it mathematically, but basically it allows you to prove something to anyone without revealing the intermediate steps. So for example, I want to enter to a disco, and normally the security guard says, hey, give me your ID. And in your ID, you have everything. So your name, your address, and everything. But you just only want to prove that you hold a valid ID and you are more than 18 years old. So this mathematical, cryptographic, magical system allows you to prove that you have more than 18 years old without revealing any more information. So here you can use this technology for saying, hey, I don't want to say who I am, but I just want to say you that I'm able to vote. So, okay. So then what the voter sends the vote to a ZK virtual machine. So it's a Turing complete machine that can work with this private data. Then, well, it's called a sequencer, but basically the sequencer reads the information from the blockchain, process a batch of votes, and send back the votes to the blockchain. And then we have, as the blockchain doesn't have like good storage for data, we are being respalded by decentralized storage systems, which, let's say, is a distributed database that can contain the census. But at the end, everything happens on the blockchain. Everything is verifiable, and you can maintain your anonymity. And of course, you can have all these properties to create like the proper digital voting system. Okay, so now we can vote freely without censorship, privately, anonymously, without coercion. So we solve it. Okay, but okay, that's just the technical part. We need to put this into the hands of society. So we need to make this easier to understand and easier to use. So there's one thing that started in more or less in 2017. It's called DAOs, which are decentralized autonomous organizations. And for me, it's super important because this is an example that prove that digital voting is technical and social feasible. So this decentralized autonomous organizations are formed by a group of random people that doesn't know each other. They have different interests and so on, but they allow to interact between them in a decentralized and trustless way. So the central authority's power is distributed among participants, so decisions can be made collectively by the stakeholders. There is automation. Operations are automated by code, ensuring that the rules that they predefined are enforced impartially. We have immutability because this is like a property of the blockchain. So decisions after the governance process are irreversible, and information is tamper-proof. And also is inclusive. Anyone can engage. Internet is open, and anyone can engage. So for me, it's like an experience sandbox for governance that is actually working. Here I put like some DAOs that are actually working. MakerDAO created what is called a stable coin, which is like a form of representation of value that is tied to the dollar. And there are lots of economical mechanisms for maintaining like this parity with the dollar. But this is all governed by random people around the world. We have nouns. What the fuck, which is a group of artists that united together to create like a common brand, and they decide everything in a distributed way. And then we have Arbitrum Foundation, which is more or less this part here that allows to discharge computational power from the blockchain. So you calculate everything, let's say, out of the blockchain, and then you publish verifiable cryptographic proof that everything was executed correctly here. Okay, and well, as I said, I've been contributing to the Vogdoni project, and one of our missions, mainly the main mission, was to be able to make people to use this technology. So we created a digital voting system. It works, it's fine, but we should give it to the people. So, well, adding lots of abstraction layers, creating a not so good UI, but understandable by the people. We accomplished since 2021 that a lot of people voted freely from their home at any time, anywhere, without using their smartphone. So you are in the metro, you open your mobile phone, you go to the feed of your social network, you say, oh, there's a voting. Do I agree that the bus stop will be constructed in the next 2 weeks in that street? Yes, I vote. Cool. And this was used in the Catalonia parliamentary elections in 2021. We call it 14 fruits because, yeah, there are some legal concerns that happened because, yeah, the government basically don't want to have like a provision of what people will vote, and this in some countries illegal. So we voted fruits, and people in this case use it their ID card, which is an identification issued by the government of Catalonia. So they use this digital identity for voting and casting their vote. This was not a really high-stake election, but this one, I think it's really important. Here, Esquerra Republicana is one of the most prominent political parties in Catalonia, and they asked the people that voted for them if they wanted to invest the actual president of Spain, is from the Socialist Party, and yeah, they used a digital voting technology for proving that. I mean, for proving that they are not the ones that privately were like deciding the next president of the Spain, but they wanted to give people voice, so they were able to do so. So that's a number that was calculated during the election, but basically more than 7,000 people voted to support that the new president of Spain will be supported by this political party, and then yeah, we have a new president in Spain. Well, we revalidate the president. So what I wanted to express with these use cases is that we are here, the technology is ready, and this works, and it's the solution for the problems that digital voting have been dealing with in the past 25 years, because it's transparent, it's secure, it's auditable. You can track your vote. You can be sure that everything was counted correctly. And I mean, we have a lot of problems with votings around the world. That I don't trust you. You cheated on the elections. You voted twice. Blah blah blah. So this is like a technological solution that fits for all. So well, what's next? Advocacy. So I think we have the responsibility to spread the world, the word in the world about this, because it's really important that since some years ago, the technology is ready for doing this kind of things. So the technology is ready for giving back the power to society. We can vote more, we can decide more, we can implement things like liquid democracy, where basically if we vote for someone for the next 4 years and at some point they get crazy and they avoid to do everything that he or she promised, we can just withdraw our vote and we can vote directly to the thing that is being decided on. So we will try to start on things that are not, that doesn't have like very high stakes, because I mean the technology is new. There can be some problems, we don't know. I mean, but the cool thing about this is all the code is public. Anyone can audit it, anyone can check that everything was done correctly. And if there is some bug in the code, it will be found. And it will be found in a short period of time and not like 5 or 10 years later. So this is really important. Then fail. No, fail is never an option. So we can learn if we fuck things up. And then we will end up succeeding. I mean, the revolution of digital voting is here. For me, it's super clear. And this is how we will vote in the future. We are a digital society. We cannot keep making decisions in an analogic way. So that's the thing. Thank you so much. If you have some questions, I will be very happy to ask you.
You can say, yeah, you can
Okay.
say.
Thank you so much.
And about blockchain voting, um, I mean, for me, it's very exciting. Corruption, all of that, and I'm also excited about like indirect or dynamic voting, and also like points distribution. Uh, I really love that point. One thing I'm curious is, for example, in this case that you used, you mentioned voters having voters ID, right?
Yeah.
What are the devices? You've also mentioned voters able to vote from the convenience of their homes.
Mm-hmm.
What are the devices of the voters? We know electricity and all of that. Like, in this case that you've used, were there any like research or testing in a way that the voter device cannot be cannot have a program by a hacker that can read the the voter action to predict the vote, because we want this to be very
Secure.
yeah. So
Yeah.
if there is a program on the user device, I don't know if the users are using like a mobile phone.
Yeah, and the phone was hacked.
Yeah, and then it was hacked. This data is collected not in the Web3 system, but before it even
Yeah.
gets into the system. What are some research, or have you? You didn't talk about like test cases or this kind of things, or kind of effects that you predicted or have found or have tested, and
Yeah.
whether
That,
things like this.
that's a really interesting point, and I don't have an answer for this for the moment. And this is a hardware problem. If your device has been tampered, there's nothing that you can do against it. So that's why we need also open source hardware. Most of the hardware nowadays is closed source. So we don't have a way to verify how hardware works. So we need also to push on the direction to use mobile phones or computers that have the hardware open source so anyone can test it. And also, if we talk about software, we need open source hardware, software systems. So your mobile should be running a hardened mobile operating system. And you should be able to detect in advance if your device has been tampered or not. So there's no easy way to solve that, especially because most of the technological companies, for example, Apple was a clear example. Everything is, I mean, their kernel and so on, it's closed source. So I think Android is a good way to go. We should open everything. We should test everything, and well, maybe we will find some stuff that it's really dangerous for us, but there's no other way around.
Okay. So, for example, the Tasmania
Hmm.
government have not considered like taking responsibility of what kind of devices use to pass
No, in this case, anyone from their laptop or smartphone was able to vote. So yeah, you can make certified hardware and so on, but we are not there yet. Thank you so much.
Okay, thank you for this. I will.
If someone has more questions, I will be around, so
Exactly.
you
I will
can.
stop it because
Yeah, we are late.
short of
Sorry.
time. But again,
Sorry.
enjoyed it. Thank you.
Thank you.
I would just like to do like a quick 1 minute, just I promise. So we have like some beers, something to eat. So it's the most important part, I think, right? That's good.
Yeah. It is.
But one thing that I want to say to you guys that follow us on Instagram. We started a Discord server because we're like young people, and like it's really awesome that we're like But we received like the first message on Instagram about people that are looking for front enders and they want like to post a job and we want like a chat about with you guys. So please enter in the Discord. And thank you for coming again. And see you guys in the next one. And give feedback if you guys want to see like more topics like that.
There's a section on Meetup platform for feedback, so we read everything. So feel free to leave a message to us. It's very important.
So that's it. Thank you for the message. Thank you.